Hello and welcome to Zig's Math Lessons. I am your host, Zigglediet B. Stunk. Here at this channel, we learn and become the best science, technology, engineering, and mathematics students for miles around. I'd recommend you watch these videos with pencil and notebook handy and maintain the policy that if it's in the video, then it goes in your notes. Now let's begin. Functions, concept, and notation. We could start with some vocabulary. A relation is a set of ordered pairs. This could be, but it isn't necessarily, points on the Cartesian plane, like 5, 2, 7, 1, and so on. A relation, a set of ordered pairs. Ordered means that order matters. So, for example, this is 5, 2, not 2, 5. The domain. The domain is the set of all of the first elements in the relation. So take all the ordered pairs. The domain is a set of all the first elements of the ordered pairs, sometimes called the x values. The range is the set of all the second elements in the set of ordered pairs, or the y values. I recall as a young student, I was trying to remember domain. Was that the X or the Y? Well, D comes before R in the alphabet, and so D is the first element and R range is the second elements. A function. A function is a relation, so it's a set of ordered pairs. It's a relation with a special property that for each X value, there is one and only one Y value. So a function is simply a relation with a special property. Here's an example of a relation, which we just said was a set of ordered pairs. Now, this is a very simple relation. Many relations have infinite numbers of elements. In other words, infinite numbers of ordered pairs in them. This is a simple relation. It's a set of ordered pairs. The domain is the set of first elements. So the domain are these guys, 5, 7, 9, and 11. So the domain is the set of first elements, the x values, while the range is the set of second elements, or y values. These guys, 3, 1, -2, and -5. That's called the range, the second elements. Sometimes functions are represented with these mapping diagrams, which is just one bubble with some numbers in it, and another bubble with some numbers in it, and some arrows. Notice these arrows have tails and arrowheads. So these ordered pairs are 1, 4, that's 1, 4, 2, 4, 4, 16, and 6, 36. The domain of this relation is the first elements, and the range of this relation is the second elements. Now the question arises, are these relations functions? Well, we can see that there are sets of ordered pairs because the arrows with their tails and their heads, the arrows themselves represent the ordered pairs. So they are definitely relations. The question is, are they functions? Let's recall the special property. Function. For every x value, there is one and only one y value. So let's take a look at this first one. For the x value of 2, there's only one place to go, 5. For the x value of 4, there's only one place to go, 5. For the x value of 6, there's only one place to go, and again, it happens to be 5. So we can say that for every x, there is only one place to go, or there is only one second element, if you wish. So this one is a function. Let's look at this second example. For the x value of 8, there's only one place to go, 2. For the x value of 5, there's only one place to go. For a second element, 4. But wait a minute, there isn't only just one place to go. There's a second place that 5 goes. It could go to the y value of 6. So for y, there's more than one place. There's more than one second element. There's more than one y value for this x value of 5. There's in fact 2 possible y values. And so for that reason, this one is not a function. Again, are the relations functions? So let's check. For 5, there's 3. For 7, there's 3. For 9, there's negative 2. For 11, there's negative 5. So for every single one of those x values, there's only one choice for a y value. So this first example is a function. Let's look at the second example. For 4, you can go 0. For 3, it could go with 3. For 2, it could have the y value of 2. And for 4, it could have a y value of 1. Wait a minute. For 4, there could be a y value of 0. For 4, there could be a y value of 1. For every x, there's only supposed to be one y. So this one is not a function for this reason. 4 could go to 0, or 4 could go to 1. Usually, oftentimes, functions are represented by graphs. A graph is, for example, a line on a Cartesian grid. And every single point on that graph, on that Cartesian grid, represents an ordered pair, because every point on the grid has an address called the ordered pair, or the coordinates of the point. So there's this thing, it's called the vertical line test. You can look at a graph on a grid and test it using vertical lines. If all the vertical lines touch the graph at only one point, then it is the graph of a function. So we can test it by drawing vertical lines and seeing if they intersect the graph more than once. Let's do some examples of this. Here's the graph of a grade 9 line. It's the graph of y equals 2. This blue graph. It's the graph of y equals 2. Now, if we start drawing vertical lines, there's a vertical line, and another one, and another one, and another one. Every one of those vertical lines only intersects the graph once. We can't draw a vertical line. Vertical means up and down. We can't draw a vertical line that intersects that graph more than once. Therefore, this one is, yes, a function. Y equals 2. Let's remember our grade 9 math. It's a horizontal line. Another example. How about the line, which I have drawn very boldly here, x equals negative 3, that vertical line. Okay, let's start drawing vertical lines and see if we can get one to intersect it more than once. Vertical lines, drawing vertical lines. Look at this one. This vertical line intersects that line x equals negative 3 many times, an infinite number of times, in fact. So this one fails the vertical line test because a vertical line touches it more than once. So we have to say not a function. Another example, another grade 9 line. Now this is the line y equals 2x minus 5, or if you prefer, mx plus b from grade 9. And it's a line with a slope of 2, with a y-intercept of negative 5, as we can see. And here's some vertical lines, and you can see that every vertical line only touches it once. If it touches it only once, not more than once, then it is, yes, a function. In fact, all lines are functions except for vertical lines. Moving on. Here's a grade 10 graph. This is called a parabola. It has a vertex at 3, negative 2. Yes, 3, negative 2. Let's look at some vertical lines. All the vertical lines touch it only once. So when you were in grade 10, you were actually learning about functions, but you didn't know it because they didn't call them functions. They called them parabolas. But these are, in fact, functions because they're sets of ordered pairs that pass the vertical line test. For every x, there's only one y value. This is, yes, a function, because the vertical lines touch it only once. Let's go again. Again from grade 10. This is a circle centered at the origin with radius r. If you recall this equation, x squared plus y squared equals r squared. This is a circle centered at the origin, radius r, which is the square root of this right side. So the graph of x squared plus y squared equals 9 will be centered at the origin with a radius of the square root of 9, which is 3. So that's why you'll notice that the radius of this circle is 3. 3 to the right, 3 up, 3 to the left, 3 down. It's a circle centered at the origin, radius 3. And let's take a look at some vertical lines. Well, there's a vertical line that touches it twice. So this one's failing the vertical line test and so is not a function. Not a function, because some vertical lines touch it twice. And you might notice that when y was squared, it turned out to be not a function. That's interesting. Moving on. Well, what a pretty graph. This is called a cubic. You haven't studied this before, but y equals x cubed minus 4x squared minus 11x plus 30. X is cubed. And when x is cubed, it forms this kind of a pattern. Kind of a parabola where one side is bent back up. And let's draw some vertical lines. And we can see that, yes, all the vertical lines touch it only once. Therefore, yes, this is a function. In fact, this association between elements of one set, called the domain, and elements of another set, called the range, is a mental construct made up by people called mathematicians. It's a mental construct called a function. It's just an association between one set of usually numbers and another set of numbers. And for the following years of your math education, math is largely about this concept. I'm Ziggleby Biestunk, and thanks for watching. If you liked it, leave a like. If you like the content, please subscribe. Check back later for updates and new videos, and I'll see you soon.